So much for attending Fundamental Physics Program Analysis Group meeting. I know some people asked, didn't we see the astro decadal a while ago? Just to clarify, NASA has several divisions. Each one of the divisions have their own decadal survey. This one is for biological and physical sciences. And I would like to remind you, after the last decadal survey, one of the outcomes was a cold atom lab. And that was at first really the coldest atoms in space. I would like to introduce John Callas from JPL, who will introduce the main points of the decadal and how we as a community can help NASA to interpret the decadal and the program in fundamental physics. Thank you so much. And also introducing Mike Robinson from NASA.
Great, Marianna, thank you very much. Thank you to the Kavli Institute for hosting this special session as part of the workshop. Again, I'm John Callas from JPL. I'm the Fundamental Physics Program Manager for NASA, and joining us in the discussion today is Mike Robinson and Marianna Safronova. I'm going to start with this. This is the recent announcement of the Chinese putting an optical lattice clock in space. So it's like, what are we doing? They've already done it. So I hope we can light a fire under the community and light a fire under NASA that we need to get going here. Okay, so what I want to talk about is I'm going to briefly go through the National Academy's Biological Physical Sciences Decadal Survey report. It's online. I encourage you all to read it. But we'll have a brief summary of that. And then I want to talk about how we're going to respond to the decadal. And I've structured some ideas here to present to you and hopefully get your inputs and follow up with some actions. So let's talk about the decadal. Now, the decadal is like reading the Bible or the Constitution. We can all come up with our own interpretations and spin on this. So you'll hear a little bit of my spin as I go through this today. The survey came out with 3 themes and 11 questions. The themes are adapting to space, living and traveling in space, and then probing phenomena hidden by gravity or terrestrial limitations. And then there are 11 questions organized amongst those 3 themes. The most relevant one for us today is number 11, which is what new physics, including particle physics, general relativity, and quantum mechanics, can be discovered.
Are you sharing over Zoom?
It should be on Zoom.
I see it on Zoom.
Great. Okay, so what new physics, including particle physics, general relativity, and quantum mechanics, can be discovered with experiments that can only be carried out in space? I mean, that's the objective of the NASA Fundamental Physics program, is to use the unique environment of space to explore new physics. Now, there are a couple other questions. 9 and 10 could probably be interpreted to do some research in quantum systems as well. But this is sort of our driving question for us going forward. Okay, there are 25 recommendations in the decadal. I've just listed 4 here, and the ones that I think are relevant to fundamental physics. So 5.1, NASA should substantially increase resources dedicated to producing and understanding the answers to the key scientific questions detailed in this report. Goes on to say, identifying new principles of physics that only can be discovered through experiments in space, include those governing particle physics, general relativity, and quantum mechanics. Right? And then 5.5-2, fundamental physics in space. NASA should facilitate durable formation of collaborations, what we're doing here, efficient knowledge transfer, working in multidisciplinary teams. The scope of the address multi-decadal science. Key scientific questions should include ground-based infrastructure, theoretical and experimental physics, precision measurements, and technology development with private sector participation. Should be coordinated with missions in which biological physical science research is one among several whole of government objectives. I'm emphasizing these words because there's some certain themes here that I'll summarize in a moment. Perhaps the most direct recommendation for us is 6-2. NASA is to pursue the development of the probing the fabric of space-time, or what's called PFAS initiative, in this decade, only if it can obtain substantially greater than 75% funding from external, in other words, other NASA sources. I'm going to go through the key recommendations, the key mission recommendations in a moment. But keep this 75% in mind. We'll talk a little bit more about that. And then 7.9 is a global statement in which to retire many of the key scientific objectives, blah, 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 that it should increase the funding towards a level of an order of magnitude above the current funding level before the end of the decade. So biological physical sciences gets about $85 million a year right now. So they're talking about ramping that up to something like $850 million a year in 10 years. Now, fundamental physics is about 1/6 the budget of VPS as a whole. The hope and the expectation is that a rising tide is going to raise all boats, and so as the funding level increases throughout VPS, that fundamental physics will also experience a funding increase. Okay, so here are the research campaigns that are recommended in the decadal. There are two. One's called BLISS, Biogenerative Life Support Systems. It's a $1.7 billion program over 10 years. And the other is called Matrices, Manufacturing Materials and Processes for Sustainability in Space. That's $3.7 billion over 10 years. So those are two big multi-billion-dollar programs over the next decade. The one, what they call beyond NASA anchored, or a multi-agency opportunity, is PFAS. So they're saying only go forward with PFAS if you get substantially most of the funding from outside of NASA. The 75% requirement, I think, is unusual and unprecedented. I would assert that it kind of hamstrings us in a way, because it's hard to show leadership when you're asking other people to contribute more than you're willing to contribute. But I think there are ways we can work with this. I mean, obviously there's a lot of investment going on in fundamental physics outside of NASA for the development of the technologies and techniques that would apply to this. So in a sense, we're already doing this right now. I'll mention one other notional concept called PROMO. It wasn't recommended, but it was described in the report. But again, these two research campaigns and then PFAS are the main recommendations of the decadal. Okay, so let's talk a little bit about what PFAS is, the probing of the fabric of space-time. It says in the decadal, precisely measuring the curvature of space-time, and what does that really mean? And thus testing the understanding of fundamental physics at a level of precision 100,000 times what is possible in terrestrial experiments. This includes testing relativistic gravity by measuring the curvature of space-time near planets and other massive objects, searching for violations of fundamental symmetries, something we've certainly talked about, searching for fundamental forces, additional forces, searching for variations of fundamental constants. That's certainly been discussed here. And then goes on in another bullet saying, probing the hidden nature of the universe by searching for dark matter and dark energy and other exotic low mass fields. And then it talks about a quantum network of optical lattice clocks may permit an early detection of gravitational waves. So they're really covering the waterfront in terms of all the physics that you could do with such a mission. And then testing whether the gravitational field has a quantum aspect to it. That's yet another dimension to this exploration. So I put this up here because it doesn't have a specific scientific focus. It describes a very broad focus. And so that's one of the emphasis I think we should have here with the FunPAG. And then the committee places top priority on a systematic development of optical lattice clocks in space. So that was the one technology that they emphasize towards PFAS. So one person would read PFAS as we put an optical lattice clock in space and see what physics we can do. But I think most people in this room would agree that each of those scientific objectives that are listed there would have a very different architecture to try to investigate. Okay, so coming out of this decadal, I collected a set of several themes. You know, up at the top it says NASA, the lead role of NASA is forming the hub for this, which is they're emphasizing that NASA needs to work with other partners, other agencies, other institutions to get this done. You know, and it mentions, you know, commercial entities. So these bullets are mine of what I came up with the themes. And I start off with what I call the 5 I's or 5 inters. Interdisciplinary. So if we do a mission that's going to be looking for dark matter, a variation of fundamental constants, you know, if it's a optical lattice clock, it could also do geodesy, navigation, timing, communications, which is an important partner field to try to investigate. So that's the interdisciplinary part as an example. It's interdivisional. We would work with NASA Astrophysics Division, NASA Heliophysics Division, NASA Planetary Division, and others to see if we can have cooperative missions. If there's a spacecraft going to a target that would be of value to have a precision instrument on board, that's something we would explore. Interagency, it's not going to just be NASA, it's going to be all the government agencies that are relevant. You know, NIST, DOE, DOD, NSF. It will be international. We will work with all of our partners around the world to try to make this happen. We are working with them today. And then it's intergenerational, and this is an important theme here, is that right now I would assert the community is not large enough to support such an ambitious mission of putting a ultra-precise instrument into deep space. We need to build up that community. So that means that we need to get students, we need to get postdocs, we need to get early career hires, and we need to provide the resources to institutions so they can bring on, train up the workforce that would be necessary to support such a community. And that's going to take years. I mean, this is more than a decade effort going forward. We would work with the commercial community, both commercial providers of instrumentation, as well as commercial providers of launch services and hosting in space. You know, the International Space Station is scheduled to be retired in 2030, so that's only, 7 years from now. The expectation is that there will be commercial providers of access to low Earth orbit for scientific experimentation. We would partner with those. Nonprofits, I was interested to note that many of the presentations so far at this conference, people have listed nonprofit organizations that support their research. We would certainly engage with them for participation. Rideshare is that if someone's got a launch or someone's got a spacecraft and they could create an opportunity to fly an instrument, we would look at that, perhaps for a technology demonstration mission. For example, I'll mention right now, I talked with the Veritas project. The Veritas is the delayed mission to Venus. They had descoped the Deep Space Atomic Clock 2 from that mission. I confirmed that they have retained the capability to the interfaces and the launch capability to fly an instrument in that space, perhaps another clock, maybe a different clock. They're looking at a launch no sooner than 2029, but maybe in 2031. So there might be an opportunity there to get a rideshare with a host spacecraft for technology demonstration. And then the last theme I have here is there are a range of opportunities for spaceflight. They start with the ground, balloon missions, suborbital, orbital missions, missions to the moon and to Mars. And moon to Mars was a very big thing of the decadal survey. And I'll just emphasize, biological and physical sciences is a huge part of the decadal survey. Fundamental physics was just one component of that. So these are my takeaways from the decadal. So now let's talk about what a timeline for response, or what's going on right now with the decadal. Biological and physical sciences held a headquarters internal retreat on the decadal at the end of September. This is a very high-level retreat. NASA is soliciting inputs right now from the field centers. These are very high-level inputs. They're just to sort of establish some outlines on what a response might involve. NASA plans to submit an initial response to the decadal by mid-November. And again, this is expected just to be at a very high level. And it's probably along the lines of, yes, we thank the national academies for the recommendations. We accept their recommendations. We are working through developing specific responses to each one, something like that. More of just a letter of acknowledgement. There's a second retreat at headquarters, and a headquarters internal retreat in early December. Mike Robinson will be a participant in that. And then sometime early next year, there's going to be a whole of BPS, meaning not just headquarters, but the centers. And then probably shortly thereafter, some sort of a community town hall early next year to talk about the decadal. And then the earliest, I would say, meaningful milepost to respond to is the budget planning for fiscal FY 2025 begins early spring of 2024. That's the first budget that could respond to the decadal. And so I think us as a community should be prepared to have some initial responses for the near term for that planning cycle early next year. Okay. I'm just going to pause here for a moment to see if people have any questions or discussions about the decadal survey, the themes, before we go into our formulation of response. Mike?
So just one thing that I think is key with the decadal, which John, I don't think you mentioned, is that there was this recommendation for an order of magnitude increase in the BPS budget. But they said until we get a substantial increase in the budget, that we should focus on those key scientific questions, i.e. that number 11, and not on those campaigns. That's not to say that in answering those key scientific questions, we can't prep ourselves to move towards, sort of the PFAS type mission. But that key scientific question, number 11, did have several research areas under them, and it included clocks and entanglement and atom interferometry. So that's all within the decadal.
Questions?
Any other questions on this? Yeah.
I'm wondering if you can elaborate on this recommendation that 75% of the funding come externally. And I'm curious about two things. Is external, does external include other divisions within NASA, such as Earth Science, that is investigating atom interferometry for geodesy? And then also international, like can ESA or whoever be partners for this?
My assessment is that the interpretation of that 75 is that 75% of the money comes outside of NASA. So if it's other money from another division, that counts only against the 25%. But how do you count that number? Is it money that is going to be spent in the future, or is it money that's being spent now? Because one could make the argument that already 75% of the funds to support this area are outside of NASA, because it's DOE, it's NSF, it's the other international agencies that have been spending money in this area. And that NASA is a very small player right now, so we're well under that 25%. But if it's when you start a new mission, what we call a phase A start to a new flight program, does it mean that the budget for that 75% has to come from outside of NASA? That's a different question, and that would be a little harder to do the arithmetic on that. But I think in the near term, it's not a constraint on us, because I think in the near term, it's going to be a broad-based program moving forward, trying to pursue many different fronts.
Anyone on Zoom have a question? Yes, Peter? I think you can just unmute yourself.
Hey, Marianna, can you hear me?
Yep.
Mm-hmm.
Great. Hey, and this might be a question internal to NASA or for Mike. On the last chart, you mentioned that each center is sending input to BPS. Here at Goddard, I guess the small community here hasn't had that opportunity. So Mike, do you know who we should be reaching out to make sure we get our voices heard?
Yeah, great question. So let us know. So it would be me, it would be Mike, it would be the FunPAG. We intend that this group, this open collaboration of the fundamental physics community, would be a conduit to provide that inputs to us. So anyone who has thoughts, questions, comments, they can always contact me or contact Mike, and we'll make sure those inputs get through.
Peter, I'll reach out to you this evening.
Other questions? Oh, and Maria?
Thank you. This is very naive, but I mean, with the quantum initiative, is there any overlap that NASA has with the quantum initiative, or how much leverage can be?
Yeah, it's a good question. So there's the National Quantum Initiative. NASA is language that includes NASA as part of the reauthorization. I actually don't know where that stands. Mike, do you know where the NQI is and what that might mean?
So as folks know, the NQI is ending this year, the first 5 years of it, and the initial one included as primary members only NIST, DOE, and NSF. It's widely expected to include others this year, including NASA. There was a hearing in front of the I forget which board it was, but in Congress about reauthorizing the National Quantum Initiative. It included a NASA panelist, one of 5. And if you listen to that, it's online, it's open to everybody, so you can go and download the transcript of it. But everybody was, including all of the people on the committee, were very positive about including NASA in the NQI. So, but you know, we have to see what actually is authorized in there, and that hasn't come out yet. So.
Okay.
Okay. Let's proceed.
Yeah, let me move ahead here. So what I want to do is talk about how the Fundamental Physics Program Analysis Group provides NASA with that essential input, because we're an analysis group, we're the community, we are the experts here, and we will help our NASA decision makers in this process. So the decadal left a pretty wide boundary conditions on fundamental physics. As you see in the language, it's a search for new physics with clocks, gravitational effects on quantum systems, cold atoms, atom interferometry, entanglement. So it mentions a broad palette of scientific research. So we need to put together a roadmap. You know, a roadmap is a destination and a path. And there might be multiple destinations and multiple paths. So the destination is the science we want to do. What is it we want to try to explore? And the path is, how do we get there? You know, what techniques or technologies are necessary to do so? So I'm here today to say to all of you that I think we need a set of subgroups, a science subgroup to develop a community census on the science approach, something in the NASA language we call a science traceability matrix. What are the fundamental measurements that you want to perform? And what level of precision or what figures of merit do you need to achieve on those measurements in order for them to contribute? So what level of measurement precision is required to make progress on those questions? I mean, are we going to search for dark matter? You know, and what range of masses or what level of sensitivity? Are we going to, you know, test for variations of physical constants? Are we going to look for violations of symmetry? Are we going to detect you know, gravity waves? You know, what is the science and what is the level of precision? And again, this is focused on what we can do in the space environment. And then, you know, what technologies or techniques do we need to achieve those scientific objectives? So I think there needs to be a second subgroup focused on, you know, what is the current state of the art for the different technology paths? You know, what do we need? What investments do we need to move them sufficiently forward to a particular level, technology readiness level, TRL level, which is the language that NASA uses to assess the state of a technology. So this is my proposal to all of you, that we would establish such a subgroup. The roadmap development, this is a broader topic. I see that it has to be structured in a series of timelines, and I've broken it into just sort of 3, near term, medium term, and long term. And in the near term, and these are just sort of gut feels for what the timeline should be. The near term is 1 to 3 years, fiscal year 25, 26, and 27. And then medium term is sort of 3 to 7 years beyond that. And then longer term is 7 to 15 years. And what I see is the near term is starting to build up the community, starting to make investments in institutions and facilities such that we can advance the state of the art. The medium term is coming through with perhaps technology demonstrations. And then the longer term are flight missions. Do we actually put a PFAS class mission forward in that time frame? Obviously, each period would be, a range of options that have to adapt to the actual budget. And as we go forward, it's going to be dynamic. It's going to change as we learn things and as we discover things. We close off certain paths, open new opportunities with new discoveries. So there'll likely to be a series of gateway questions that we'll have to ask ourselves whether we're making sufficient progress along a particular objective. Is the community large enough to support a flight mission? Is the technology readiness level sufficient to make a proposal for a flight mission, and so forth? Obviously, we'll need trade studies. When we go to, say, we're going to fly an optical clock, what species? Is it strontium? Is it ytterbium? Is it a lattice clock? Is it an ion clock? Is it a network of clocks? Is it dual species? Those will all be trades, and they get traded against, opportunities. There might be an opportunity for a flight mission that maybe is not going to push the fundamental physics questions to the level of precision that we want, but it may pathfind some technology for later possibility. But in the near term, I think we need to be prepared by spring of next year to say what we think the investment should be for fundamental physics. Okay, so I was mentioning some of these are the kind of questions that we would ask ourselves as we develop how we go forward with things. What science campaigns offer the best return on investment with respect to fundamental physics? I mean, there's some campaigns that may be very expensive, may be all-consuming of resources. There are others that may be more affordable, and that's a trade we have to make because there'll be a finite budget. And so we'll have to come up with timelines and cost estimates associated with each of these. What campaigns might lead us to natural partners and missions of opportunity? As I mentioned, there might be a ride opportunity to Venus for a clock. And so, is that something we want to take advantage of? Because we don't have to pay for launch costs, we don't have to pay for a spacecraft. All we have to do is provide an instrument that interfaces. I mean, it's not as simple as that, but it creates an opportunity. What technology and techniques are required, and their state of readiness is obviously something we need to be able to answer at every step along our roadmap. And, just what I call decision point questions, is the community large enough to proceed forward? Well, I'd say today it's not, but we want to try to build on that. Do we have the necessary infrastructure? Do we have the laboratories? Do we have the test facilities to be able to advance these technologies and to build flight missions? Are we interfacing with the right partnerships? Do we have the right people on board? Are we making the right progress towards meaningful architectures for a flight mission? Okay, so it comes down to 3 actions. We establish a science subgroup. If so, who will lead it? Who's going to participate in it? What I would ask is that we have some sort of a product that comes out of it, that we draft a white paper or what might be a traceability matrix. I say 6 months because that would put it spring of next year, which would help to start to influence the early planning budgets for BPS. And similarly for technology. I see these as both living documents. I mean, what we say today will evolve over time, especially in the area of technology. But there are certain technologies that we have a need for, and yet others have needs to similar technologies. I mean, everybody wants, small, efficient, reliable, stable lasers in space, whether it's for optical clocks or virtually anything that uses a laser in space. And so there's a lot of teaming that can go on with that. And so letting the outside community know our needs for technology is beneficial because they maybe discover that there is a source for some of these. And then establish a near-term budget planning group, and that this would be to come up with recommendations for the planning project process in the spring. But that's not the end of it. Of course, there would be the continuation of the longer-term road mapping activity. So that's what I'm going to ask of the fundamental physics community, the participants in the FunPAG, is that we move forward on actions like this. So I'm going to stop here and get people's response to homework assignments. Yeah, June, do you want to wait for the microphone?
I just have one quick comment about, it's a great idea to establish a science subgroup and a technology subgroup, but I think it's also really important when you identify those two leads, they actually form a little subcommittee. And so the ideas go back and forth between science and technology, because oftentimes scientific ideas give rise to new technology, and technology has to be developed in supporting science. And that way, it's kind of a feedback loop.
I agree. Yeah, great suggestion. I likely think that there'd be people on who work on both of these committees, and by no means are these meant to be closed. I mean, the hope is that we will get participation from everyone in these, and there'll be contributions from people in both of these groups.
Thank you.
Right.
And I think, but June, I think it's a great idea. Maybe perhaps there'll probably be at least a couple of leads for each of them, and maybe a few interested people. So there may be an open meeting for both groups, like every month or so.
Yeah. So you mentioned like sort of developing the community, and one of the issues that I kind of see is the fact that I'm a guy in a university. I know people who, for example, work on clocks, stuff like that, but I've got no connection to NASA, right? So when it comes to say things like, how do I find out who in NASA might be interested in the sort of things that I'm interested in, so that we can actually form a functioning collaboration, right? Mm-hmm. And this is like, the DOE, we know people in national labs, stuff like that, just from what we've interacted with. So how do you think about we might solve that problem of finding people inside NASA?
Great question, Sujit. This is a problem I have myself. NASA has a broad portfolio of research, and how do we find who's doing what? And the hope is that the FunPAG will attract people who are interested in collaboration. And hopefully there'll be communication within the FunPAG of opportunities and researchers. I'm certainly going to keep it, an ear out to opportunities both within NASA and other agencies. I mean, we want to, for example, see if we could set up a formal relationship with NIST in, clock research. I think that, to having, visiting scientists that are supported that could travel to different institutions for periods of time to do joint research. And I've been trying to reach out to DOE and NSF and others, and I know Mike has been reaching out to his DOD colleagues to find out who we can get together. And there are also these other groups. There's the NESC quantum sensors group, which is another part of NASA that's just focused more on quantum sensors that we're trying to bring into, to make them aware of the FunPAG as well as be aware of their research. Mike, did you want to say something about that as well?
Yeah, well, I just wanted to, is this on? Yeah. Just to address that question, NASA across the board is pretty open about their program scientists and program managers' names. For instance, there's a Rose's NASA research announcement, which is open all of the time. The topics aren't always open, but the topics are there. And for instance, there's a fundamental physics topic, which actually lists my name, and I think it's my email address as well. But at any point, that's a good place to start. Another place to start is if you know somebody, feel free to write me, and I'm happy to try to point you in the right direction. In terms of the quantum, there is an internal to NASA quantum community of interest where we all get together sort of once a month. So if it's a quantum thing, we sort of know who the right people are. If you're looking for other areas like something like gravitational waves, well, I will know that that's in my sister division, astrophysics, and I could probably point you to somebody that's doing that. But
Hi, Animesh from the UK, University of Warwick. So I would very much like to reiterate June's point that there be some cross-pollination between the subgroups. But I also have Surjit's question, but now from an international context. I mean, there's a large community of people interested in these things in Europe, for instance, in the UK. So how do they engage with this process in a formal way?
Yeah, great. So how do our international partners engage? So one of the constraints we have is NASA generally doesn't send funds to outside the country. It can send funds to US collaborators of international partners. So we can't fund research directly in other countries. We generally work with their sister space agencies or scientific research agencies to provide in-kind support. But in terms of communication and collaboration, the FunPAG is open to everyone on the planet. So, and we don't necessarily even restrict it to this planet. It's open. So we hope that our international partners will also take a role in this and will work with us. I mean, we already have programs right now where we work closely with ESA, with CNES, with DLR, with the Canadian Space Agency. And so we would welcome expanding that and work closely with those colleagues, because there's a tremendous amount of expertise around the world. It's not all, here, it's certainly not all at NASA, and we would welcome that. So let's use our collegial opportunities to create those connections. And again, participate in the FunPAG. Sign up for the mailing list.
And by the way, if you think that there should be some other additional groups within FunPAG and you have idea for one, please, so I'm a chair of the FunPAG, so please let me know. If you go to FunPAG website, there is a website. If you've never seen the link to the website, send me an email, I'll send you the link, and you can sign up to get all of those emails about events and information. I actually have a question about the budget planning group, because frankly, I'm completely ignorant about the how NASA does the budget, because you said, okay, 80 million, 1/6 is fundamental physics. So what is it you actually want us to do about the budget?
Okay.
Like,
actually, that sort of gets to
or
where
that would be like you and Mike sorting the budget.
Yeah.
Or you will, because as I said, it's, or you would like us when we, establish those two groups, we would not be saying, okay, we have $1 billion and that's how we are going to spend them.
Let me tell you a little bit about the current budget planning. So there is a 5-year budget plan. So there is a 5-year budget plan that exists today for fundamental physics, but it's pretty flat out to 2029. The hope is that will increase. And so what I would expect, if there is an increase, that NASA management comes to us and says, okay, we want ideas across BPS for expanding the budget in the near term. And they may give us guidelines as to how much of an expansion. And then we would come in with our proposals for saying, okay, well, we want to establish this facility, we want to fund these research grants, we want to put out, more solicitations for this, and provide the justification as to why that's a good thing to do now versus, later. And that's part of the discussion. That's part of the process of why I want these subgroups, because those would feed into that process, that we could then provide the necessary justification for why they should fund fundamental physics now with this level of funding versus putting it over here in biological or putting it over into other parts of physical sciences. Because if you read one interpretation of the decadal is they said, spend billions of dollars on biology and physical science, fundamental physics, you got to find a fairy godmother to fund your effort. We want to not have that, the realization, but instead come in with a broad-based program that makes sense. It's probably going to be a slow ramp up. Again, we want to do the long lead things, and I think one of the first things is to build the community. How will this go forward? So I'm looking for volunteers. So I want you to think about participation in these kind of activities. What would be involved here? In my previous job where I was working in the exoplanet community, we did the Extreme Position Radial Velocity Initiative for NASA, and we had a series of subgroups. And they met bi-weekly via telecon for an hour or two. And this is an unfunded mandate. You're not going to get paid to do this. The hope is that you feel this is important enough to contribute, that you can represent your interest area, and that it may be successful in future funding and future support. But I don't expect this to be more than the kind of thing of a few hours every couple of weeks kind of involvement. I mean, many of you have a list already of what's the science you want to do and what's the measurements. I mean, you pull out your papers and you pull out your previous proposals, and that becomes the feedstock for this. So, I'm not expecting a large labor contribution to be part of supporting these subgroups, but I do expect activity, and I do expect that the leads for these subgroups would produce some sort of a product, a white paper. It may just be a few pages long, or maybe a table or a matrix of information. And that it's not necessarily a formal document. I mean, it could just be a Google Doc out there that gets updated with contributions from people over time, but that becomes a meaningful feedstock for the planning process. So, yes. Oh, wait for the microphone.
This is a zero-thoughter question from someone who's more familiar with astrophysics. How do you define the P in BPS so that it's distinct from the astrophysics division? Because a lot of things you mentioned, dark matter, dark energy, gravitational waves, they all seem to lie in astrophysics. So how do you define yourself?
Good question. So how is the science that we're trying to pursue in the fundamental physics program different from the science that's being pursued in example for in astrophysics? Because astrophysicists are interested in dark matter and dark energy and gravity waves. So astrophysics is an observational division, so they build instruments to do these deep space observations. Fundamental physics is to do in situ experimentations in the space environment. And it's a gray area, and there's a tremendous amount of overlap, and we hope to involve the astrophysics community in this process so we can address some of the needs and interests that they have, as well as get their participation. It's kind of historical why fundamental physics is in biological and physical sciences, because it was originally as what kind of experiments could you do on the International Space Station? And it were mainly biology experiments, and then the Cold Atom Lab came out of the last decadal, and that was implemented. And that was sort of our flagship entry into fundamental physics in space, but it was done under biological physical sciences, which was actually in the human exploration division, and only recently got moved into the Science Mission Directorate at NASA. So that's kind of the history of it. Follow up? Wait for the mic.
Yeah. At first it sounded like a good division, but if you think about what the talks we heard, the dark matter is coming from space. The gravitational waves are produced by objects in space, so it is observing phenomena in space. So I understand it's
a technique different. I mean, the science may be similar, but
is the technique different? Than Lisa say?
Well, we're doing atomic clocks versus building a 2.4 meter Roman space telescope. It's a historical organizational bifurcation. I mean, there have been arguments for maybe fundamental physics should be moved into the astrophysics division. So this is where we are today.
But just a general answer that in this case, whatever is sent to space will actually conduct experiment. Like for example, with clocks, I guess you can say that you turn the clock on and observe, and then it kind of becomes fuzzy. So I kind of see your point. But frankly, I think this is a very good question. And the fact that you have such a distinct topic, which is distinct from the rest of the decadal survey, I think frankly, I see it as a problem, because it's this question 11 is very different from everything else.
Frankly, I see this as a good thing, and I don't think it's worth spending a lot of time with this group at the moment trying to distinguish what things belong on what side of the fence. Mm-hmm. We should move forward, and if there are a Venn diagram, a lot of overlap between two communities, that's a good thing. So I just wouldn't worry about this question very much at this time. maybe down the road when there's either budgetary or political or institutional boundaries, it might be worth trying to figure out. But right now, I don't think it's worth spending too much time on. This is Dana speaking. Hi, folks.
Anna?
Right. I mean, very similar, not the same though. So, for example, we know now that atomic coatoms experiments are becoming complex, and sometimes funding is significant in order to make them work. So, one question is, given that there could be overlap, I mean, maybe not between the quantum community and the experiments that are going to be proposed here, how much is going to be a win to have leverage with other funding agencies, or trying to, I mean, how much opportunities can NASA win, for example, by taking advantage also of other research that already started, funded by other communities? Maybe it's good, or?
Yeah, certainly we would look to take advantage of opportunities with other agencies. I mean, Department of Commerce funds NIST, and NIST is this tremendous, set of clock expertise. And, I can't imagine we would not involve NIST heavily in, activities going forward. The challenge we have with federal agencies is everyone's interested, but no one wants to take part of their budget to move it over into this other program. No one wants a new liability unless the new funds come down specifically for that. So, but I hope at the grassroots level that we as a community can demonstrate to our stakeholders the great value of interagency and collaborative research in these areas, that we can achieve these common objectives together.
Yeah, I have another quick comment. I think Mike mentioned two things. One is the connection with DOE, the other one is NQI. And I've actually served on couple committees. One is on the decadal survey on AMO, the other one on the NQI committee. And it's a tremendous support for NASA. What you are establishing is a very ambitious scientific goal. And you are, also, is the community big enough to support all these? Mm-hmm. And I think if you think about the global scale, if you can involve DOE, DOE in principle has been doing fundamental physics with all the budgets going to accelerator physics for many years. And DOE is trying to pivot to find new ways to do fundamental physics. If you can get a DOE involved, in a real effective, not a symbolic way, where the DOE scientific community, both grassroots, as you mentioned, as well as a funding agency connection, I think that would be a sea change. This will really truly be a big community doing fundamental physics, using new technology that going to space, where we're developing Earth-based technology and testing out, because it would be very costly, as Anna Maria pointed out, and you need these commitment. And I just feel like on those committees, we point out all these important things, but a very, very real action, I would say, is happening between, say, DOE or NASA.
I agree completely with you, June. We've been trying to reach out to the DOE, and we'll continue that. You're right. I mean, the fundamental physics budget is right now about $15 million a year. DOE spends tens of billions of dollars on fundamental physics research. I mean, 3 orders of magnitude more. And, you look across the globe. So we want to team with all those players. So that's a very strong theme here.
I would like to actually comment on the DOE. So DOE had recently requested one more document on the quantum information science for the high energy physics. And I've personally did put under synergistic activities the link to the BPS decadal, and also explicitly I put the recommendations from NASA BPS decadal into this document for the DOE. In a couple of different places. So, I mean, we of course have to follow up, but nevertheless, it will get to folks at DOE, which presumably be planning something like next quantized, or maybe, I mean, there is a hope that NASA, the DOE will have a quantum program as opposed to actually as a small effort. But in this case, I do not have any ideas what exactly is happening. So I think there were several couple of other questions. So I think you wanted to comment.
Well, no, do continue on the question.
Well, this is a long time ago. I just wanted to comment on the issue that we should not spend too much time on. I mean, there are instances, for instance, putting macroscopic optomechanical superpositions in space to watch their sort of expansion in time, experiments that require long freefall times. And these are experiments that can only be done in space. And these are, according to your criteria, sort of experiments to be done in space as opposed to observations being done in that astrophysical phenomena.
I think, Surjit, you had a question? Okay. Anyone else? Or people over Zoom?
Okay, yeah.
Thank you. I have a question about these 5 orders of magnitude improvement compared to ground measurements, basically. That seems a bit terrifying. I don't know a lot of science cases where you could win 5 orders of magnitude by going to space. Can you comment on that?
Yeah, I don't know specifically where that 5 order of magnitude came from, but it does remind me of something, an issue that we need to deal with in the FunPAG, is that many of you are familiar, for example, with this STE Quest European proposal. And it got dinged scientifically because it was talking about, well, if you get a null result, are we going to really spend tens of billions of dollars to get a null result? You know, we as a community have to communicate to our stakeholders the importance of scientific measurements, and that you don't necessarily make a discovery, but you make progress towards eliminating a space of discovery and narrow down the focus area of further exploration. And so part of coming up with the science subgroup to make the science traceability matrix is to say, okay, what are the measurements we need to do? What level of precision do we need to achieve on these measurements? Do we need 5 orders of magnitude on some of these? I mean, some, you know, order of magnitude moves the needle. Others, you need 3 orders of magnitude. I mean, I think we're talking, I think sort of as a general rule of thumb, that before you spend $1 billion, you have to be pretty confident that you could get at least 3 orders of magnitude improvement on whatever measurement you're trying to do. So that's kind of the thinking here. So $1 million mission, 2 orders of magnitude, but $1 billion mission, you need 3 orders of magnitude. Something like that.
Maybe just following up on the importance of null measurements. I think for me, when I look at, say, the EDM experiments that come from Acme or others, I find it very compelling when they're able to show, oh, if we improve this much, we rule out this particular flavor of supersymmetry, and if we improve this much more, we rule out some other proposed theory. And so then it's a little bit less of a null thing. It's like you're actually saying that this model that people think is a good model actually doesn't agree with our experiments. And maybe we could try to figure out something similar for like these equivalence principle tests. Although I'm not familiar with any presentation like that where you say, oh, you can rule out this class of modified gravity or this whatever, right?
I'm sure there's some law that says every order of magnitude improvement in precision rules out n orders of magnitude of theories out there that try to explain it. So, yeah.
I have a comment which kind of also touches upon all of those things. And this is, you raised a very important question, is the community large enough? How to grow the community? And if you think about, if you send a Webb telescope to space, a lot of people are going to be using that data. So the question is, when we think about possible missions, when we think about science, we also can think about what would be the users of those data. Like what kind of data would be actually producing? Because this is a very different way of thinking that we are sending one null experiment in space. because all of those would be very expensive. So in Cold Atom Lab, it is to extend a user facility and it's been designed like user facility. So we perhaps can also, think out of the box and think about it somewhat differently than we thinking about, okay, not me personally, I'm a theorist, but when we actually in our lab, even collaborating with other people. Because for example, now, let's face it, AMO experiments are getting much more collaborative, much larger, there is much more networking, there's much more collaborations as a groups. So here we may think about maybe a paradigm of how do you go to space? What exactly would we like to have in space in 30 years, which is quantum? And why do we want to do that? So I would like to mention that the establishment of the fundamental physics analysis group, while its first action is to directly deal with help on decadal, it's in part is to provide a vision for the future, because essentially we're in the very, very beginning of this road. So thinking maybe beyond what we normally think, okay, I'm interested in this experiment and we are going to send to space, a few other people are interested, but maybe we can, think broader in this case. And of course, if it's a, facility to take gravitational wave, you're kind of back to observation in the same case. But in case of experiments, that would be interesting to think about how it actually can serve the wider community and think about in terms of the data production. For example, if you have a clock in space, it could link all the other clocks on Earth, etc. But maybe it could be more of a, a hybrid facility, etc. And frankly, I don't exactly know how that could look like. But we could think about beyond really one single experience in space. We should think about like what we would like to see there in our lifetimes, because it all takes time. And as a chair of Fundamental Physics Analysis Group, I would like you to be inventive. And maybe that's kind of beyond what we immediately need to do, but nevertheless, thinking about the science questions and the technology can be.
Yeah. So actually, I want to make a couple of comments about this issue of measuring zero, right? So first of all, one useful analogy that I've found in talking about this kind of stuff to the public, people like this, is that, science is about discovery. And so I would say that I often make the comparison that is like playing soccer, right? In soccer, the point is to score a goal. And if you don't score a goal, you don't win the game. And for us, that's like discovery, right? So scoring a goal, of course, is very hard. And but does that mean that just because it's hard, you don't try, right? You've got to keep trying. The second more pertinent point is that if you think about it, right, like somehow we have created this artificial thing that somehow there needs to be a discovery for it to count. So let's look at DOE. They're trying to spend billions of dollars on something called Dune. And the actual new physics discovery reach of Dune is extremely small, right? So even though from the public perception, we are sort of talking about it as though like, oh, there needs to be major discovery, it's not clear to me that at the level of the government, that somehow discovery is what really matters, right? Because otherwise you wouldn't be spending so much money on Dune. Mm-hmm. So I think like we should kind of move past this, claim that we're measuring zero and sort of portray it differently.
Thank you. That's exactly what I meant. That essentially we're studying science. I mean, if you would like to understand essentially the physical nature of the universe, and that's how that is framed. But what I'm saying is that the specific missions or instruments can be understood broad, and of course we can think about more immediate things and further away and things. But the point is, I think I've at some point put a slide of quantum technologies in space. And I had a lot of space on one slide, so we're just not quite yet there. Also, I would like everyone to think about who would like to be the lead, because I would like to get some names while we're actually still here. So do you have any comment from people on Zoom? Comments, questions?
So yeah, Marianna, I would say, I wanted to say that's what I want to do is either we get volunteers or we're going to ask people to participate in these. And we have some ideas. We're going to use, we have an executive committee. We talked a little bit about this, and I have a few ideas, and Marianna has a few ideas, and Mike has a few ideas of who we get to lead. And we're thinking of co-leads, so not one person has to do all the heavy lifting, and that we also get a sort of a diversity of leadership in these things. So, yes.
Could people on the executive committee identify themselves? If you're in a room, stand up.
Yeah,
or
yeah,
raise your
please.
hand.
That's a good point.
Up.
So,
if you're in a Zoom, can you kind of, put some?
Here I am.
yeah,
Standing up doesn't do too much good, but staying here.
I see a few of you, so yeah, just identify your hand by hand or something. So we actually have quite a few people here, so I think Julie.
Yeah, we put you on Anna too. You're supposed to
not very rare. Okay, so thank you. So and we have Peter and Dan and if please. So as you see, yes.
Thank you.
Sit down. So as you see, we already have executive committee established with about 15 people. So if you go to the FunPAG website, it tells who we all are. As a chair, if you're not sure how to participate, or you have an idea, or you actually have a piece of text you want us to consider, I mean, first you can just send it all to me. And then, of course, everyone who would like to participate in those efforts, first, we are not necessarily committing ourselves to bi-weekly meetings. I try to hold usually meetings when I have to meet, but there has to be a discussion. Because so there could be some sort of just a document first pulling ideas, and then we'll meet to discuss and brainstorm them. And I think there definitely has to be some cross meetings between the groups. It could be also that people can organize themselves and clocks, interferometers, optical links, etc. So which could absolutely be separately. So we don't really need everyone at every meeting, and sub-community can organize themselves. So for example, the cold atoms, ultra cold atoms effort, and others, and also for science, and also people who are from particle physics here, please tell it to your colleagues. We definitely need more people from particle physics, from gravity. We have, I think, at least 3 people from those communities at the executive committee. And we also understand that this field is very young. The entire field of fundamental physics with quantum technologies at the level which is right now, it's very quickly developing. So presumably there are many other ideas, because people frankly have not really thought what you could do with quantum technologies in space. So many of us have our particle physics and gravity colleagues. Ask all of them this question. What can you do with quantum technologies in space which you can't do on Earth? So invite them to be a part of the FunPAG group. In this case, it's while we have a decadal, there always can be a mid-decadal, and there will be a next decadal. And we should not think like, okay, we work for 6 months and then we'll just like whatever happens. And this is not the case. Fundamental physics group right now, technically in place, I think, executive committee in place for 3 years, unless of course NASA wants to shut us down. So this is not a short-term response. This is a long-term vision, and I think in part what you see is a science subgroup. It is a long-term vision, because presumably we won't be able to do everything we want in 10 years. We just want to see where we start. And a part that I agreed to be the chair to see what is that we actually want to do in space eventually, and to have it as evolving vision as well. So other questions?
Yeah, I mean, this is your opportunity to tell us what you want and what you need. I mean, that's essentially what we're asking for in these groups, is to tell us what you want and what you need. And then give us the justification to bring that to our stakeholders, in this case, NASA.
Thanks. So I did want to ask about the subgroups. I know we all want to ask for an order of magnitude increase in the budget as soon as possible, but is that part of what you're asking from the subgroup? Some budget discussion, something to feed into the or the planning through 2030?
Yeah, a great question of clarification. For the science subgroup and the technology subgroups, I'm looking for long-term vision. Where do we want to go with this field? The near-term budget will benefit from these, but I see that's in a sense a separate question, because it is a near-term question. I want to be prepared to respond to any increases in NASA funding with a strongly justified program that can be traced to a long-term vision. So if we say, well, in order to eventually do a gravity wave mission in space or a dark matter mission in space, we have to have a larger community. So we start the investments for that community now, and that's why we have to start those investments now, as opposed to them saying, okay, well, we can fund that, 3 years from now or 10 years from now. No, it needs to start now on some of these. So the long lead, things like that. And my expectation is that it's going to be, if there is an increase, it'll probably start off with a modest ramp, given, we all know what the federal budget turmoil is, and how it affects other, agencies. So one can't expect, a huge windfall, but we should be prepared to come in with a justified, credible vision and budget in the near term, and that's where I want to be by the spring of next year.
So just one comment on that, John. I like the word justified. So the decadal that came out is very broad across all areas of BPS, particularly fundamental physics. It left the door open for us to do, it lays the basis to justify a whole lot of things that we could do. Obviously, we can't do all of them. And to move forward in the budget process, to actually build the fundamental physics budget so that we can do something, it really does have to be justified. And as John mentioned at the beginning, there's an awful lot of trades that are going on out there, and we have to build a roadmap that tells us how to do those trades. And it's the folks that are in this room and online that have a much better idea at how to do those. And so, from my perspective, that's what I'm looking for the group, is to help answer those questions. To talk a little bit about, Jun, one of your comments earlier, getting like DOE involved and other agencies. Getting other agencies and international partners will do nothing but help us justify the program and grow a budget. One of the big trades, however, is every agency in the federal government has a different mission, and they're going to want to be doing different things, right? One agency is going to want to do something in low Earth orbit. One agency wants a circular orbit. One agency wants an elliptical orbit. For whatever they're doing, geodesy or fundamental physics or gravitational wave detection. We need folks that are experts in these areas to show where the sweet spots overlap and help us make those trades to justify a program for the future.
Just thinking out loud, if you ask me how, based on Marianna's comment on how we can involve broader community, particle physics, because definitely a complication is that there is barriers between the different communities that we are just starting to talk. So maybe if you ask me what could be a way to try to synergize more communities and try to come up with something that is useful for everyone, could be to continue more kind of the programs that we had this year in KITP. Maybe try to in the next, maybe one of the goals of these subgroups could be suggest programs where the community can bring together and be, for, I don't know, 1 month sitting, this type of synergy between different type of communities trying to brainstorm possibilities, because this is, although of course talking between different members of a group is very different than trying to get a lot of people thinking on ideas. So that would be my suggestion.
Yeah, I actually, I think it's a great suggestion that we plan to have another NASA fundamental physics workshop in the springtime, and we haven't yet decided on what the theme or the focus of that will be, but it's likely going to have a strongly influenced by the decadal, and we may decide that we ask for papers that address some of the things that you mentioned about, okay, come up with a collaborative mission concept, or come up with a research area that exploits certain advantages that exist already, or things like that. So Yeah, I hope to have more of these FunPAG meetings that are opportunistic at other conference forums, and yeah, we want to continue that discussion.
Even these longer KITP programs, I mean, time is not, because sometimes being a meeting is okay, but it requires time to materialize. Right?
Yeah.
So my extended program
I agree. It would be great to have an extended program. You know, as we all know, there are almost as many conferences to attend as there are theories that explain fundamental physics, right? So finding time in people's schedule to schedule things. That's why the fundamental physics workshop might be a venue where we might have an extended conversation or series of sessions at that, or that kind of thing. In the springtime, in time for the budget planning. A month long. Wow.
Well, this is a month. This is 5 weeks program. This is just end of the conference. But that is a quantum. It's a quantum novel ideas in quantum metrology. This is a 5 week program.
Oh wow. Okay, I didn't know that.
The idea was to bring communities from high energy to AMO. I mean, really this type of we need a nice venue where people are willing to come and spend some time. Otherwise, people will not come. So
right.
So a venue where people see beneficial to come and spend 1 or 2 weeks, 3 weeks, or program trying to brainstorm ideas. And this, I mean, this was proposed by people, so we just need to propose this type of ideas to the board.
You sound like you're volunteering. I'm fairly serious. So, I mean, by the way, Lars just asked yesterday to propose new KITP programs. So, okay, it did sound like volunteering. Okay. Okay. Right. So, I mean, it will take us a couple of more people to coordinate. Okay. So, I mean, but this is actually a very serious suggestion, because it could be KITP programs of new physics discoveries in space. And I mean, it could have some overlaps with people from, astrophysics division and so on. It doesn't, so we actually know how things are done at NASA. So, or it could be more focused on experiments, but I think it's interesting, new physics in space. I think it's, yeah, and particle physicists, definitely particle physicists. So, as I said, this sounds like a great idea, and I mean, you can tell us where the deadline is. But one of the more immediate, venues we can use is, and I have to see who the chair is, but Precision Measurement Group will meet with DAMOP this year, which means there is a Monday workshop at DAMOP. So that could be one opportunity to suggest. INDM organized 5 of those initially, but now Precision Measurement Group runs it. It's a full day workshop. So, and that would bring the AMO community. It's fairly well attended. It's also essentially free, meaning that you don't have to pay for rooms, and APS organizes everything. So, if anyone wants to volunteer themselves to help Precision Measurement Group to do that, if they, of course, would like to cooperate. But I think Tanya Zelivinsky is the chair, so we could suggest to her, and that will be one possibility. But I like the idea of KITP program, so because it sounds more like for KITP than for, say, Aspen, for example, which is a bit more particle physics. So, but that is a wonderful idea. So, again, if you would like to do that, Fundamental Physics Analysis Group is happy to assist. But of course, that would be a fantastic venue, because that could bring a lot of people from different fields together. It will take, how much in advance are those? Are we talking 2025? Yeah, but I think we'll have some more ideas by then, but that's one of the only ways to grow the community, to frankly have, schools, and we are probably not quite yet mature field enough for a school about space for quantum sensors, but overlap, I think that sounds like a great idea. Right. Okay. So if you're interested in this, and would like some help from FunPAG, let us know. But that sounds like a great idea.
Okay, I kind of sense we're kind of wrapping up here. I'm going to just put up one more slide.
I have a question to Mike. So, because that's something you mentioned before. Do you want us, as a science definition and technology definition team, comment on very specific things that the decadal survey said? For example, it said something about clocks and Lagrange points and mission to Uranus, and it said a lot of things. And for example, optical link to ISS. Do you want us to specifically comment on those things and like where we as community stand with those things or not? So, I mean,
so if there's specific things in there that you feel like you need to comment on, absolutely. But as I mentioned, it's very broad. I mean, it really leaves the door open to a lot of different things. The PFAS mission itself, it mentions everything from putting an optical lattice clock at the L5 Lagrange point, and then it goes on to say, well, maybe you could put the old deep space atomic clock, which is a mercury ion clock, on a mission to Uranus, and it says things like, well, maybe you wouldn't get as much good fundamental physics, but you could do some really good time transfer with it. What I would really like to know is, in terms of physics return on investment, and I know that's hard to measure, measured against what kind of budget it would cost. I would really like to know which of those or anything in between we really should be going after. And that may be not a question that we can answer right now, but it may be a question where you say, hey, if you set up a science definition team in this particular area and fund it at some notional level, that after a year or two study with that science definition team, they'll have a better answer for you. I don't know what those science definition teams should be right now, but I have a feeling that the folks in this room have a much better idea than I do. So those are the types of questions I'm looking at. And so the roadmap that, so first off, BPS has not responded to the decadal. We have not developed what our response is yet. We're really still digesting it, so we don't know how we're going to go forward on it. But I do suspect that we'll be building roadmaps, right? And those roadmaps are not just going to say, okay, we need an optical clock mission to Mercury, right? It's not going to be that specific. It's going to be like, you need to build your ground program, and then the ground program should be in these areas, right? To include clocks, to include entanglement, to include interferometry. And you should focus those ground programs on these areas that other people aren't focused on, that are, or have a niche in space. Right? We haven't done those roadmaps now, but over time, over the next year or two, that's what we'll be doing. And then, as John mentioned, we'll have gateway decisions in between that. Hey, look, we've really made progress in this area. It's leaning towards we should be doing a mission in this area, right? Those types of things. But we really need the experts to weigh in. Right now, all right, well, this is really the open question. You really need a science definition team in this area. I can't stand up 60 science definition teams, but we can stand up a few if they're necessary. So the thing about the decadal is, again, as I mentioned, we can use the decadal to help justify the program to OMB, to Congress, to our leadership in NASA, to ask for budget to support it. But the decadal also being so broad, we really need a good justification over and above that to make sure that we can do it.
What we need is a fairy godmother.
Right. So, right. Again, I'm just going to say again, the PFAS is not the only thing in the decadal. We have key science question 11. It does not come. Key Science Question 11 has everything that we want to do in it, and it does not come with this 75% needs to come from outside of NASA, right? Everything in Key Science Question 11 can come, right? But also everything in Key Science Question can actually go and help with a longer term PFAS. Anyway, sorry.
Okay, great.
Thank you. I was just wondering if you don't mention something which was mentioned in the decadal survey, that's okay.
Okay. Thank you all very much for your time and attention. We look forward to your participation in these activities going forward. And of course, you can always reach us with questions, answers, or volunteer opportunities.
And before we leave, okay, I can say, okay, I'm happy to be co-lead for the science team, but I would like to see any hands which would be interested to be co-leads on either science team or the technology team. There's anyone? Okay.
One brave soul in the back, 2, 3.
Technology.
Yeah.
Okay. So
I mean, we know who. Yeah.
excellent. So send me an email, okay? And then and just let me know which team would you like to be a co-lead on. And I think it'd actually be good to have a few people because you know, eventually it is good to have more expertise. Especially, it'd be nice to have someone from particle physics on co-lead on the science team, definitely. So send me an email, we'll sort it out, and we'll establish. And again, it's, you know, our decision as to how, you know, much we meet and so on. So also, please send me an email if you want to participate in either one of those. So in this case, we'll make sure that, again, all FunPAG, and I presumably will post something on one FunPAG, but I'm happy to be a point of contact. So send me an email not only if you would like to be the co-lead, but also if you'd like to participate, and just indicate which one of the teams you'd like to be participating in. And sometimes we'll have, you know, coordinating meetings. And again, we will try to keep the number of meetings as low as necessary. So because sometimes we will need to talk, and sometimes a few of us can be at the same conference, but then eventually a document will be due, and we would like to actually have it as a process as opposed to that we suddenly need to produce a document. So we will definitely would like to, that will require some thought. So if you'd like to participate in any way, please send me an email, we'll sort it out. There will also be a call for those teams who are there with understanding that those two things would be related. So for example, the science definition team could define a broad spectrum of devices. But the technology definition team, for example, can, you know, work out specifically the readiness level and the other things. So those two actually very interrelated topics. And if some subgroups could be formed within the teams, for example. It just, again, it's all very new. And now, thank you so much for coming. And I would like to thank everyone on Zoom. Peter, I see you have a question. Yes, please. Peter?
No, I was just volunteering. I'll send you an email.
Great. Thank you, Peter.
Excellent.
Okay, thank you, everyone. We have lunch in 10 minutes.
Yep.